This is PreCalculus 12, Chapter 2.1. We're going to be looking at properties of radical functions, specifically the square root function. And the domain of radical functions, the even roots, is x is greater than or equal to 0, and y is greater than or equal to 0 for the range. Invariant points occur where two functions have the same value. And for the original function and the square root of that function, they have the same value at y equals 0 or y equals 1. Because square root 0 equals 0, square root 1 equals 1. So we have the invariant points here. Y equals 1, y equals 0. Okay, they meet here. If we look at 1/4, x equals 1/4, so that's roughly about here, then the square root of x equals the square root of a quarter equals a half. So what we have is 1/4 is smaller than the square root of 1/4. Okay, because we just said the square root of a quarter is a half. So a quarter is less than a half. Now we can test more values between 0 and 1, but you'll find that for all values of x between 0 and 1, x is less than the square root of x. This means between 0 and 1 for x, we plot square root x above x and below one. So if it's between 0 and 1, you wouldn't be plotting above 1. Let's take a look at x equals 4. That's here. And we can see that this continues and the square root of 4 is below it. Okay, so square root x equals square root 4 equals 2. So 4 is bigger than square root 4. And again, if we take any value above 1 and test it, we'll find that x is greater than square root x. This means that for x is greater than 1, we plot square root x below x and above 1. Okay, again, the invariant point is at 1, so it wouldn't go below. This is true no matter what f of x we choose to plot with the square root of f of x. F of x could be a quadratic, it could be a cubic, or any random function. Let's take a look at a quadratic here. Our invariant points are here, 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 here. So now we're looking at the y values. We're not looking at the x values because we're taking the square root of the y values. And just so that you're not confused, we said y is equal to x here. So we were always looking at y values anyways, but I only wanted to deal with one variable, but now we have to consider the y values. Okay, so between 0 and 1, we plot above but below 1, and then above 1, all these values are above 1, we plot below f of x but above 1. Same thing over here. Between 0 and 1, we're plotting above, and above 1, the y values, we're plotting below but above y equals 1. And that's square root f of x. Now if we look at a cubic function, We're not looking at the cube root, we're looking at a cubic function. And we're taking the square root of this cubic function. So again, we start off with the invariant points. Between 0 and 1, we're plotting above f of x, but below 1. Now we're above 1 for f of x, so we plot below it, but above 1. And we continue. And again, we're plotting the square root of f of x. So these rules apply for the 4th root, the 6th root, all the even roots. We're not practicing on any of these questions, but they still apply. Now, if we're doing odd roots, it's slightly different. And for this chapter, we're only going to consider the cube root, the domain for cube roots. X is all reals. And the range can be all reals, but depends on the radicand. That's the function inside the cube root. So the invariant points occur, again, where the two functions meet. And this is actually y equals -1, or y equals 0, or y equals 1. So we're adding another invariant point. And this is because b/c, the cube root of -1 is -1. So let's look at some examples. So we plot the invariant points, 1, 0, -1, -1, 0, 1. Okay, let's plot the points above x-axis first. Again, we want to plot above f of x, but below 1, between 0 and 1. Above 1 and below f of x for any values above. And same thing on the other side, cube root f of x. Now, below the x-axis, the rules are reflected. So between -1 and 0, we're plotting below. Between 0 and -1, we're plotting below f of x, but above -1. And below -1, we plot above f of x, but below -1. Okay, let's take a look at this cube function. Again, we still want to plot -1, 0, and 1. We'll do the part of the curve that's above the x-axis. We go above, below, above, above, and below. And below the x-axis is the opposite. So we plot below f of x. And it's okay to exaggerate it slightly just to make sure that you're not following the curve exactly. You need to be below the curve. And below -1, we plot below -1 and above f of x. Here, it only reaches -1, so we just plot below. There's no need to plot above because it doesn't go below that. And we plot below again, but above -1. Okay, so let's go over the rules again. For all f of x between -1 and 0, f of x is greater than the cube root of f of x. This means between -1 and 0 for f of x, we plot the cube root of f of x below f of x and above -1. For all f of x below -1, f of x is less than the cube root of f of x. This means that for f of x is less than 1, we plot the cube root of f of x above f of x and below -1. And if you need to be more accurate, use a table of values. And for the square root of f of x, to find the domain, you need to solve for f of x is greater than 0, because that's the domain of the Radicand. And this generally means we are solving a quadratic or a cubic inequality. If you're lucky, it's just a linear inequality. So we have to look back to PreCalc 11, where we did quadratic inequalities. So we must consider the outer intervals or just the inner interval. So let's look at some examples. Y is equal to the square root of x squared plus 4. If we look at the discriminant, yes, we're using the discriminant again. B squared minus 4ac equals, b is 0 here, so 0 minus 4 times 1 times 4, that's -16. -16 is less than 0, so no solutions. Okay, so no real roots. And because there's no real roots, it means it doesn't cross the x-axis. And it looks like this. So all the values are positive. So the domain is x is all reals. How do you find the range? Well, this is already in vertex form. Y equals x minus 0 squared plus 4. Vertex is at 0, 4. And we're plotting the square root. So we need to do the square root of 4. This is the minimum value. So y is greater than or equal to 2. Square root 4 equals 2. Let's look at the next example. Okay, so we have just the radicand. We ignore this minus sign. That just means it's a reflection on the x-axis. So we're looking for the radicand greater than or equal to 0. So x squared minus 9 is greater than or equal to 0. This factors into x plus 3, x minus 3. That looks like this. So minus 3, plus 3. And this is all negative. So this is our interval, and this is our interval. And we can use a shortcut. We can just say the absolute value of x is greater than or equal to 3. And if we look here, this is where our min or maximum value is going to occur. So if we plug 3 into here, we get 0. And because this is going to be positive, this is going to make it negative. So it's always negative. So y is less than or equal to 0. Last example, 4 minus x squared. 4 minus x squared is greater than or equal to 0. We multiply everything by -1. We have x squared minus 4 is less than or equal to 0. This factors into x plus 2, x minus 2 is less than or equal to 0. So we have -2 positive 2, and we're looking for it to be less than 0. That's this inner interval. So we're looking for absolute value of x is less than or equal to 2. So our min or max values are going to occur at these endpoints here. So we plug in 2, we get 0. So 0 is less than or equal to y. It's less than or equal to. Again, the other maximum or minimum is going to occur at the vertex here, so that's 0. If we plug 0 into here, we get 4 minus 0. Square root of 4, that's 2. So, tips for graphing. You can use this, and this is going to be y1, square root y1. This will make it easier. If you just leave this function here, you can plug in different y1s, and you can check a lot of equations quickly. Okay, we'll clear. Okay, let's enter our first function, 2x minus 4. I'm not going to go square root 2x minus 4 because then I have to change two functions. I'm going to do square root, and I'm going to do vars, y vars, so right. I'm going to do y vars of a function, so I'm going to press enter, and then I want y1. And y1 needs a parameter, so we plug in x. Okay, and now we graph. Okay, I'm going to use the standard window, so I'm going to press zoom and 6. Okay, we can see our f1 or y1, and we can see our square root. If we want to see more detail on this, we'll have to change the window. 0, -1. Haven't quite got the detail, so I'm going to just make the y values stop around here. So we don't need to go out as far there either. And I'm going to make this 3. And graph. Okay, now we see the detail. This is invariant point at 0, y equals 0, and an invariant point at y equals 1. You can see that we're plotting above f of x between 0 and 1, and we're plotting below f of x when it's greater than 1. Okay, now to get the second one, all I have to do is clear this one, enter 0.5x plus 3, and I need to go back to the standard window. Okay, again, you can slightly see that it was plotting above and now it's plotting below. It's doing the two graphs when I'm only changing one. Okay, clear. X squared plus x minus 2. And graph. Okay, we see that it's plotting below f of x, and then above, and then below. And that's the TI. Let's bring up the Casio. Menu 5. And we're going to put 2x minus 4. And we have to enter shift square root. And you need brackets here. And I want y, f1. And I want y1, function 1. And I want to put brackets x just to be explicit. And draw. And there we have our function. If we want to go back and put in the second one, exit, just have to change the first one, 0.5x plus 3, and draw. And we get the same drawing. And the last one, clear, x squared plus x minus 2, and draw. And for f of x greater than 1, we plot below f of x and above 1. And here, between 0 and 1, we plot above f of x. And the same thing over on the other side. So, final note, graphing without a calculator. You know how to plot these lines, quadratics, and cubics, so plot them and use the root graphing rules. And that completes this lesson.